as the panelists are Professor Anil Dewan, who's Head of Department at the School of Planning and Architecture, Delhi. Mr. Mathur, are you there? Professor Dewan, can you please come on stage? I have Mr. Ravindra Kumar Sinha, Senior Architect DDG and DDG Works for the Central Public Works Department. Thank you. Mr. Brice, Lequette, from the international market. He's the international market manager for stainless steel for Novacel. Architect Kalhan, Mattoo, founder of OK and DXB Advanced. I have architect Bimal, Kachroo, director of Holistic Urban Spaces. I have Mr. Shival, Manchanda from ENIA Architects, Mr. Anand, Gupta, MD of Rinox, Mr. Sandeep, Singh, Head of Business Development for Jindal Steelway. Can you please join us on the stage? I'll hand over the dais to Mr. Mathur to start the proceedings of the session. Thank you.
Very good afternoon, friends. It's indeed a great pleasure and honor for me to stand before you in this special session on use of stainless steel building, architecture and construction. When we talk of stainless steel and architecture, obviously we always talk of the first big building, the Chrysler building in New York, built in 1930, which is now 93 years young, and paid cleaning. The cleaning of the building, paid cleaning was done only 3 times in those 93 years. On the other hand, in Paris, we have Eiffel Tower. Of course, it was built in 1876 or 1879, and it requires painting every 7 years. So in all these years, of course, there was no stainless steel at that time, and I think the original cost has been multiplied many, many times. And as you know, next year, the Olympic Games are going to be in Paris. So Eiffel Tower is getting a facelift again with a quick rush job, spending 60 million euros. So that speaks for itself, the value of stainless steel. The panel here and the audience are very much aware of stainless steel, so I don't want to go into too many things, but it's like I am proposing the marriage of my daughter, so I'm explaining what are her attributes, what are her good qualities, and therefore, it's important to briefly, I don't want to repeat what everybody knows, but it is excellent corrosion, everybody knows, does not require coating. Strength increases with cold work. If you beat stainless steel, the strength increases. So wonderful phenomena. Looks good with other materials like stone, wood, or concrete, glass. That's important. Easy to clean, hygienic, 100% recyclable. Good energy absorbing characteristics. Now, I mean, how to justify that it has got a good absorbing characteristic energy? I don't know if you know of a rail accident in Australia. There was a passenger train at a railway station, and at a fairly high speed, an engine came and had a head-on collision. People were there in the train, and the first 2 or 3 coaches got crumpled up on top of each other. And because it was made of stainless steel, there was no casualty. You know, the public area which is there in the beginning of the coach, that got damaged. And so that proves a very special quality of safety when you use stainless steel in railway coaches. So that is a lesson for all of us. Then good high strength resistance, high temperature resistance. You know, in case of any major fire or something, in United States, in many of those big departmental stores, they have an exit door from their storage area, which is all made of high stainless steel, because in case of fire, that gate will not collapse. People have easy access to escape and come out of the building. Also, it's wonderful, it's not only at the high temperature, it's also at the cryogenic temperature, the strength of stainless. It's tough at cryogenic temperature. Now, I also want to talk of a wonderful city like Venice. For centuries, Venice has been fighting nature to keep itself from drowning. It is under attack from rising waters, sinking ground, high tides, wind, salt water, and more recently erosion caused by the wake of hundreds of motorboats. In the last 10 to 15 years, the maintenance team of the city has used moly-grade stainless steel extensively to strengthen its defense. In this battle, stainless steel often works behind the scene, embedded in stone or brick, but in some cases it is plain sight and blends in beautifully with the old building material. So, I mean, you can go on and on about stainless steel. So I would not take too much of your time. We thought of having a short presentation. Because of shortage of time, we are not doing that. The audience here is very well wedded to stainless steel. I would rather call my first speaker to share the dais or speak from his location where he is. That is our Professor Anil Dewan, Head of Department of Architecture at School of Planning and Architecture. Professor Dewan, what I want to tell you is that why I am so involved in stainless steel in ABC sector, I am surrounded by architects in my family. My wife is a graduate from your school in 1967, not yesterday, not day before. So she is a veteran from your school. My daughter Anjali and my son-in-law have graduated from CEPT Ahmedabad. Everybody knows CEPT Ahmedabad. My second daughter did from Ansar. So I'm surrounded by architects, so there's no question of my not getting influenced by architects. And one story I want to share very quickly is about the world's tallest building. Everybody knows that in today's context, Burj Khalifa is the tallest building. It's by accident that I happened to be in SOM office in Chicago. In early days when that building plans were just finalized and there was a model there, and I met the architect, Adrian Smith, who was principal architect to design that Burj Dubai, which was renamed as Burj Khalifa because of whatever fund shortage towards the end of the project. And to your surprise, he's 22 days older than me. So you can guess my age because he was born on 19th of August 1944. At 22 days, you'll know that I will be also 79 very shortly. And his other building, which I love, is the Jinmao Tower in Shanghai. That's a tower which has got 50 floors of office space and retail. The reception and check-in area for the Grand Hyatt Hotel is on 51st floor. You have to go with a high-speed elevator. And then in the evening, if you want to enjoy yourself, go to the top roof called Cloud9 Bar. Everybody needs to be on a bar after a hard day's work. And the 360-degree view you can get of Shanghai from there is absolutely amazing. And sometimes the whole building at that level will be having a swing a little bit here and there, whether it's your second drink or whatever it is. So that's, with that kind of thing, I would like to call our professor from SPA to come and share his views, if he wants to come here or he wants to speak from there. Thank you.
I think I'll speak from here. So thank you for giving me this opportunity, and thank you organizers for making it possible for me to be here with you people today. So I was very interested in the previous session, and I would like to continue from there. So what I want to impress upon you people is that, you know, what is the difference between US, Dubai and India is that we are the world's maximum number of people. So the tallest, the biggest, the greatest and fastest ultimately has to come to India, should come to India. So if we say that so many tunnels are being made in India and it is much more than anywhere else in the world, so any sector in the infrastructure industry you take, maximum has to be in India. But what, so now it was very easy to say spend on R&D, spend on research and cultivate your academia. So I'm going to tell you how to do it. So set up labs in the academic institutions. Give a lot of stainless steel to our students for letting them feel the material, work with the material, and develop the skills, the knowledge, and the attitude required for that material. So now I'll come to COVID and post-COVID. All this time, my research area was indoor air quality and infection control in hospitals. So I would say that the built environment and the building professionals also have a very important role in there. And the doctors and the nurses would always say, no, 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 Hospital Infection Control Committee is microbiologists. It's the practices, the SOPs and all that we have. I said, no, it is the air, it is the materials, it is the touch. From one person touches another material and then touches another thing and the infection goes from here to there. This is where stainless steel and a lot of metals can really help us. But we have also to take care of the low income economy that we are in. So we have to innovate, we have to set up norms, codes, guidelines and standards. And that has to start from the academia. We have to catch our professionals very, very young, right from the first year to the fifth year. And when they get the right attitudes in school, they're going to ask for the right materials when they go out and practice. I have a lot of practicing architects here on the panel, so I would leave it here, and I would request whenever my turn comes again, you may ask me questions, or I'll add to whatever I want to say. So we have to set up material testing labs, we have to see, feel, touch and understand the materials, and then specify them and use them. And then all that was said in the previous session of the design basis report, the detailed project reports, the specifications, and then, drawings and details and all that. Thank you.
Thank you. I may like to request my friend on my left side, Anand Gupta. I mean, what I've heard is he's specializing in the handrail business with stainless steel. Now here I want to share with you that at Hong Kong Harbor, we saw a handrail made of 316 stainless steel grade with moly. And within 2 years, there was a pitting and rusting marks on that. And why did it happen? They used the right grade. Now the success of stainless steel is not only the right grade selection, how they fabricated, what was the welding like, how they specified it, whether the surface of the handrail was polished because it was on a harbor area. So even if in India, we have to put a handrail in Mumbai, and the one we put in the Parliament House in Delhi, we can save money in Delhi. Inside the Parliament House, it could be easily 3 or 4. But in Bombay, it has to be 316 or duplex grade, properly finished and polished. Yes, Anand, please.
Hello. Hi. Good afternoon, everyone. Thank you for the opportunity. And a very pertinent question. So this is a question, I'm going to talk very practical terms because I come not from academia like some of the distinguished members here, more from the industry side. And this is a question that a lot of customers will ask, somebody they're buying from. And the first answer that I would give them is, this is stainless, not stain-free. So that is the start where we have to understand that it's a product which is designed to rust less, stain less, but it can give you a lot of value for money if it's used correctly, as the question has been put. Very correctly is the choice of the grade and how it's manufactured, which will go a long way into deciding how it's going to perform after it's installed. The material by itself, it's very difficult. In fact, visually it's impossible to distinguish whether it's 304, 202, 316 duplex. And that poses an inherent problem in usage of stainless steel. In fact, we've I've been in this business for about 20 years, and the initial time we have been only exporting because in India the perception was stainless is stainless, grade ka koi farak nahi padta, and then people would spend the money and then they would lose money because it would start rusting and then they would lose confidence, and it was a vicious cycle. I think today we are much better informed, not right there yet, but much better informed. So to answer your question, if it's going to be on a high rust environment location, for example, where there's a lot of fumes in the air or maybe next to the water body, we would recommend not only 316, maybe duplex, which is much more rust resistant. We would recommend a mirror polish rather than a satin polish. Satin looks modern, but mirror is more rust resistant. And we would strongly recommend that any stainless you use in architectural applications should be ultrasonically cleaned. Now, talking to a lot of people in the business, sometimes they're not aware of this manufacturing process. Basically, it's like you take a, you see those detergent ads where you put a cloth in the tub and then you see all the dirt coming out. Ultrasonic cleaning is the same thing for stainless steel, where the impurities which are at the surface level are actually removed using this process. So many times it's not the rust, but it's the impurities at the surface which are degrading the surface. So there is a solution. I think you just have to choose the right people to go to make sure that your investment in stainless steel stays on forever.
Can I now request architect Shival Manchanda ji to speak on his international one big project he's doing of cladding material and also stainless steel in public art. These are two areas he may like to share with us.
Thank you, sir. Thank you. Hello. Hello. Yeah. I'm Shival Manchanda, Director of ENIA Architects. We are wholly owned subsidiary of ENIA Architects France, and we have been working in India since 2014. I have an overall experience of 20 years. Now, while in the last 20 years we have seen how the use of stainless steel has increased in all the projects. Currently, we are working on a lot of infrastructure projects, especially metro stations, railway stations. And we have seen how the use of stainless steel has increased. In fact, now even as sir said that, earlier there was no distinction between 304, 316. Now even clients are more aware, contractors are more aware. In fact, we have seen places like we worked on a small project for high speed. They are now putting the glazing in stainless steel. Typically the glazings are in aluminum, generally all across, but now they are using internal glazing to start with in stainless steel material. Use of stainless steel railing, as everyone is aware, has increased in all the infrastructure projects, and since it is the minuscule proportion of the overall infrastructure project, in fact, now the difference between whether to use 304, 306 is gone. Everybody says, let us use 316 and let us be, on a safer side so that it is, you can use it continuously. Particularly for this conference, I have compiled a small presentation if we can play it. Yeah. I think it's already given to him. We can play this. So I have compiled this presentation focusing on our international experience, what we have done in one project in France. There is a project which we are doing, which is ITER. It is International Thermonuclear Research Experiment, in which there are 35 participating countries. India is one of them, and it is this particular project is, no, not this one. There's another one. Or else I have another one. I can. So this particular project is basically a collaboration between 35 countries. The European Union, Japan, India. India is one of them. India has a stake of 9.1% in the project. So this principally is a nuclear installation where they are trying to create fusion energy on Earth. Basically, whatever happens in sun, they're trying to create an experiment on Earth to create energy which can be used for commercial purposes in future. So as of now, this is in a experimental stage. So we are the architects and the planners for the project, but a large, I would say, part of this project is industrial, which is already fixed. Yeah, which is already fixed. So I'll just take you through some of the slides. I know. Next, yeah, so this is a project. It is the world's biggest experiment in fusion energy. As I said, there are 35 participating countries, including India, which has a 9.1% stake. In fact, the Cristat, which is the core of the experiment, is manufactured by L&T and it is already supplied from India. Then, the experiment aims at creating sunlight temperature, which is almost to the tune of 180 million degrees centigrades on the Earth. And we are the architects for the project. And this project basically changed the building morphology, was out of question, because it was completely an industrial project where there are different heights. Something is 17 stories, something is underground, then there are various labs, etc. So changing the height or morphology or the size or the volume was predetermined function by the experiment. So the challenge was to bring an element of regularity and alignment in a very heterogeneous environment, so that we can bring a harmony to the project. The project setting was on a very secluded, hilltop, obviously to be away from the cities because it's a nuclear installation, and it's a very critical project by that way. So we used polished mirror-like stainless steel cladding material, which was chosen as a cladding material, and interrupted with Lequette steel also in between, just to break this thing. The idea was to pick up the hues of the nature, changing weather and changing sun, so that basically it kind of act as a mirror, and it can pick up those passing seasons and blend the building particularly in the surroundings. So this is the installation of the cladding material. So the cladding material panel was supplied by ArcelorMittal. It's a Trapeza range of there. The overall assembly is roughly 400-500 mm thick, where there is an internal steel, then a rock wool insulation, and the top cladding material, which is again steel. It's a corrugated steel panels. So overall, our idea was to bring a perspective in which we are saying that the stainless steel cladding material reflects what precision work is going inside this particular experiment. So this is one of the examples. The other example is just the trends in the public art. It's not our projects. I just compiled this because there is a lot of opportunities now in India even. The first project, when we passed out from college and we came to Delhi to work, this is one of the famous project in front of AIMS, and I think executed by Jindal Steel only. Courtesy architect, Vibhor Sugani, who's one of the, So the Sprouts, which is a public art installation. Another example is by Anish Kapoor, the Cloud Gate Chicago, which is very famous tourist attraction. People come, click photographs, and etc. in front of it. So the use of stainless steel has been there worldwide, even in India, but it has not really picked up. If you see, even in Delhi bylaws, when we apply for a building permission, we as an architect has to fill that 1% of the money has to be spent on public art in a project. So there is an opportunity in every public project at least to have some kind of public installation. And these are some of the pictures of CloudGate. The metal steel installation in front of Museum of Asian Civilization in Singapore in the Bay Area. So the kids like it very much. My son liked it. He was actually in love with this this installation, and basically it activates even the child's mind also, and the way they react to the overall environment. And then the famous, balloon dog installations by Jeff Koons in New York. So these are some of the examples, and then there are many more. If you see, through the web research, you will see there are many more installations. And even in railway, we are working on railway projects. There are around 1,400 railway station, and it contains a public art installation for all of these, railway station. Every station has a forecourt where you can do a lot of, public art installation. So there is a huge opportunity in India, even if it is 0.5 or 1% of the budget, but there is a huge opportunity in India to do these kind of public art installations. Thank you.
Thank you very much for a very exciting presentation. Can I request our friend on my right to share with us? They are world leaders in, I think, protection film and other things which are also married to stainless steel. We need to protect stainless steel at construction site and at various transportation and whatnot. So why don't you share what your company will be doing? And you have, I believe, a stall in the exhibition, so you can also visit his stall and ask him questions. Yeah.
Thank you very much. Can you load the presentation, please? Maybe I can go there. So thank you very much. And of course, thank you to ISSDA to welcome me in order to talk about protection film, process films. I come from a completely different world from the plastic world, in fact. So the first question would be how a plastic product can help me in order to process stainless steel, to help me to reduce carbon footprint of stainless steel. So as today, I wanted to talk about what is process film, of course, and in fact, how it can help stainless steel segment, stainless steel market to reduce its carbon footprint. So first of all, Novacel, of course, is the world leader. This is an old company, 40 years old experience. So this is not a new trend to put process films on stainless steel. So this is something that people need in order to be sure that during all processes, all mechanical transformation, the stainless steel will remain intact and pristine until the end, until the installation on buildings, on kitchens, and so on. In fact, we know that we produce plastic films. So for sure, we need to work on that. And as a responsible company, Novacel work in order to develop, to preserve, and to create a responsible community. So it comes from our product, our production, until what we can do to our customers. So here, of course, the stainless steel market. So I will not surprise you about that. We talk about buildings, of course, but we have stainless steel everywhere. So of course, buildings, architectures, constructions, appliances, tanks, transportations, you have stainless steel everywhere. And what this application have in common is the aesthetic aspect. The last panel talked about the fact that it's not only about resistance to corrosions. Stainless steel is a great product in terms of aesthetic. So a lot of customers also like this aspect. And of course, you need to protect this aspect during all the processes that the stainless steel have to suffer. So also the panel yesterday talked about the fact that we can replace a lot of material with stainless steel. In buildings, we can see a lot of aluminum composite panel, pre-coated metals, plastics, and so on. And of course, everything can be replaced by stainless steel. As a supplier of this other segment, we know also at Novacel that they use process films for this application. They know they need that in order to install it properly and to be sure that the building at the end will be completely perfect for the people. So that's why stainless steel will be also required to have this kind of process films on it. But it's even more difficult for this kind of applications because the process in order to have the stainless steel put in shape for this kind of installations is really difficult. It involves a lot of friction, a lot of pressure, and so on. So that's why you need very technical process films in order to handle that. of course, you can't apply it by hands. It's something that must be done industrially. So people that apply process films, you, producer, service centers of stainless steel, you are only buying and putting films on the surface. This is really important, but this is not what is the real goal of the process film, because the people that will really enjoy the process film will be the end users. The people that will manufacturers, that will process the stainless steel in order to make the panels, for example, in order to make the appliances and so on. So this is where people need to have all the needed information about what we can do with the process films. Of course, a process film can give a lot of advantages. As I said, producer and service centers, they have only to laminate. And for them, it's easy to cover finish number 4, finish number 8. It's quite simple. But at the end, all the other benefit that process film can bring during transformation, like laser cutting process, like bending process, like punching process, everything needs to be covered. Everything will be protected during all these harsh processes in order to be sure that everything will arrive at the end user in the perfect state. We talked about external use for buildings. Of course, films need to follow stainless steel there. So we also need to give outdoor guarantee in order to be sure that all the installation can be done without trouble and remain like that for several weeks or several months without any impact on the surface. And that's why all this guarantee worldwide, so humidity, UV, and so on, is really important. And now I will dig on the topic of sustainability. Because, of course, stainless steel is a material of the future. It's durable, 100% recyclable, the perfect solution for the future and for the world of tomorrow. And of course, as suppliers, I said, of plastic films, we need to work on that. First of all, I wanted to highlight that to use a process film is already a step in terms of eco-responsibility, because it helps you to reduce the waste that you make. It helps you to reduce the post-operation that will be needed if you damage the surface. It will help you to avoid to reproduce materials if it's damaged. So this is the first step. So it helps to protect from dust, pollution, dent, impact, and so on. And of course, according to the process of your customers, different films need to be used, because the wrong films will give the wrong response according to the process of your customers. So it is really important to notice the different need of your customer in terms of process films. And of course, we can also help you in order to optimize the process. So most of the time, it's not you that will benefit from that. It will be your customer that will benefit to have a better productivity, to have less energy consumptions, thanks to the right process film that you put on the surface. Of course, as Novacel, we work on the next generation of process films in order to consume less fossil resources, to reduce carbon footprint, because we know that our process film is part of the total carbon footprint of what you sell to customers. Of course, if you take an example of 100 micron films on 1 millimeter stainless steel, this is part of the product that you sell to customers. So that's why it's really important that if we can reduce the carbon footprint of stainless steel, it's also important that we reduce the carbon footprint of what you put on it in order to protect it until the end of the process. And of course, also, it's really important to be still fully recyclable and to take care about the waste that we will have at the end of the process, at the end of the installation. So different technology exists, in fact, in order to propose to the market eco-friendly process films. I will be quick on the first one because this is the technology that everyone knows. This is recycled content. Of course, we can put recycled plastic inside films. But for stainless steel, this is not a technology that is quite ready. The quality is not the right one in order to be sure that you have no impact on stainless steel. That's why plastic industry have to continue to work on that, to continue to work on the quality of the recycled content. But for now, we can propose other technology. The first one is what we call the vegetal one. It means that instead to have PE that come from fossil resources, we can propose PE that come from bio-based materials. So mainly vegetal oil and residue. So it's not something that comes from food or something that can grow food, in fact. It really comes from waste. So this is a real advantage of this kind of technology using the mass balance approach. So this is something that we can propose. And the third one, the third technology that we have available right now is the lean technology. It means that for the same thickness of protection, you can use a lower quantity of fossil resources. It means that the density of the product that you can use is lower. It helps you also to reduce the carbon footprint. You can have here some example of by how many we can reduce the carbon footprint. And this is a first step in order to help you to reduce the carbon footprint of your whole product. And as a last slide, in order to finish, I wanted to present you something. It's just an example of what is a product that we can propose right now. So it's not a question of we think about making green process films. It's just to show you that it's a reality. It's already something that we can propose in order to support the stainless steel market to reduce the carbon impact of their product. Because this is really something that needs to be achieved. And of course, a lot of things will be done on the stainless steel production. But of course, if you don't make any effort at the end in order to also reduce the carbon footprint of what you put around the stainless steel, it makes no sense. That's why it's really needed to make this kind of efforts. So here, for example, this is a vegetal version. It helps to reduce by 35% the carbon footprint of the product. So it's a huge impact on the total carbon footprint of the stainless steel sheets or coils that you can send to customers. And of course, you can keep all the other benefits of what you can have with a standard film that you use right now. It's not a problem, and it will only give added value to your own CSR strategy in order, of course, also to promote your actions. So you will see that you have here a print that is easy identifiable in order that your customer can see, okay, this company make an effort in terms of eco-friendly initiative in order to be sure that everyone knows all the effort you make on this field. So, as we said, we have a booth here on the exposition. So if you have any questions, feel free to join us in order to talk more about that. As I said, we are quite far away from your world. We are from the plastic world. So we know that you don't know a lot of things about that. You know a lot of things about your market, but we are here in order to link the two worlds, in order to be sure that you can respond to the request of your customers. Thank you very much for your attention.
Thank you. Can I request architect Bimal Kachroo to speak now, please? Bimal, do you have any presentation or?
Good afternoon to the steel fraternity present here. Am I audible? As Mr. Mathur already stated the name of Adrian Smith, SOM. So they are the masters and I think we are the mystics. Professor is already here, he has spoken about the national use of how to educate materials with students and put a large scale use. I think he has understood the problem rightly. See, stainless steel was discovered in 1968 for commercial use, and it was through the efforts of Cornell University when AISI and other jargons came into place. Unfortunately, it is the only material in the world which is a wonder material. Still, it has not gained the rate of advocacy in India or other poor countries because there's a paradigm of cost, which is not actually a paradigm of cost. There's a misnomer to it. Now, generally, people have talked about life cycle costs, high ductility, then easy maintenance. I'll say, as an architect, stainless steel has three very important properties, which no other metal has. One is, it has very high strength to stress ratio, to weight. This is the changing game for cost, which unfortunately most of the architects and the advocates of technology has not understood in India. Second is, it has superior aesthetics, so you don't need to have 5 materials on top of it. And third is, it's colorful. You can get a lot range of colors. So as a designer, you have right choices at the right place. Only the probabilities have to be matched. Now the issue is in India is that I have to play with 6 grades, 304, 316L, and mostly 6 grades. And where the nickel content is generally 10 to 12% and chrome is 17 to 18%. Mr. Mathur has been the pioneer in advocating stainless steel in India. He is a founder member of ISSDA, I think. So we have been requesting ISSDA also, for many times we are designing a manual on our own. Whatever we try to do in stainless steel, we used to face 3 frontier problems. One is the right material is not available with any manufacturer at the right time. My client has 2-year project lifespan. So it doesn't wait. The issue is material availability. Second is workability. Most important, like railings, other things, they are gaining momentum because there are a lot of players now in railing. And there are a lot of, there was a company initially in the 90s which used to do railing, Cure Railing and this. Now there are around 100 companies we get for a single coat. Second and most important thing is that stainless steel has not to be seen as isolation with carbon steel. Unfortunately, in India, all the designers compare with carbon steel. There's no comparison at all. See, we try to do experimental projects. Stainless steel can be a structural element. It can be aesthetic element combined. It can be a luminary also in the same steel. So if you take the trade-off of cost of stainless steel as an element in one, like in column, one single column you take. You have normally an RCC column with normal stainless steel. If you see the cost analysis of that, I'm not talking license cost right now, that will come later. Normal cost components, it has RCC cost, it has shuttering cost, then it has granite cost, or whatever you clad, ACP, you have to clad it something. Then you have to carry conduits, and then you have to put luminaries, then you have to put speakers, generally in public transit buildings in this part. So if you take all those components together, stainless steel, we have done this research and we'll be sharing with that, comes at the same cost with a higher and better grade of stainless steel. I'm talking about 316 only. I'm not talking about other grades. Second is corrosion. I know a lot of issues of corrosion. There are corrosions in stainless steel. Is not only material. There are small rusting issues in lower grades of stainless steel also. But the major issue is that you have not to paint. See, every building material, whether it's education of aluminum, hard surfaces, you have to paint it or repaint it. In aluminum, you have serious problems of silicon. After every 3-4 years, silicon ruptures and things. In stainless steel, you don't have that. So we have a lot of study on that. I cannot take your time because it's a very huge, as Mr. Mathur said. What Sir has said about public art, so it is undebatable. So public art is one place where stainless steel is no comparison. As he said, his son got in love. I also got in love with that Chicago thing, the Chicago beam. I have a small presentation which I'll make for people who are not architects, that how architecture and stainless steel can be remarried in India. I'm saying remarrying with a specific purpose, because you have to have a new paradigm shift in thinking. Thinking of stainless steel as a composite element of 4 or 5 elements, as a carrying, then joining systems. Third is, most important is, people are talking about codes. There are international codes available, so you can directly imbibe them in India. So the handicap of India, we have a problem. We always say it's not possible, but there are international codes available. See, when they can make a bridge in America, where they can make a Chrysler building in 1930s, well, Adam Smith can make changes which are in no code. But Indian architects, I particularly myself, we blame, we're not so innovative. And you have to accept it on a public dice. Indian architects, because over India, we have a paradigm of education-based jobs. So whenever there are very less architects in India will be around that who are very innovative. So that's where one change has to come. And last but not the least is that there has to be basically, I should say, a very, very systematic shift, modal thinking, a thinking of material education, where material properties will all take care of. We have factor safety in India. That's why a lot of unauthorized construction does not come down. It's already 1.5 times, material safety is 1. So we play with 2.5 to 3. It's the only country, basically third world countries, we play with a factor of safety of 1.5 to 3. So that can be taken by stainless steel at 1.5. So if you take the cost combined for any element, now if you say a stainless steel column can go like a tree-like structure in center of an airport. So it will be a structural element also, it will be supporting roof also, it will be an aesthetics without any maintenance. So what more is the material you want? The only thing is all these things have to be put up together. I think ISSDA can play a great role in that. I have a small presentation. I go very fast to it because all the luminaries are here. They already discussed. So just can you put the presentation?
Is this your presentation?
Yeah. See, there are a lot of what the future of architecture is now bionic design, which has to be organic. It has to be multiple use. Today, the buildings can be a hospital in the daytime and they can be a auditorium in the night time. So you have to do multiple use. Then it has to be recycled. Now the recapture rate of stainless steel, Mr. Mathur will bear me out, is better than zinc, steel, and copper also. So basically, it's not the recapture rate also, it is basically the last recycled content also. This one you have to please? Oh, yeah. Sorry. Oh, sorry. It's going forward only. Ah. No, sir. Sorry, sir. Back. This one? New. Now, justly we talk about sustainable design and bionic architecture. Basically, the future of architecture is in basically bioclimatic and bionic. Sir will bear me out. And we have green ratings, we have BREEAM rating, we have CASB, we have other rating systems. But unfortunately, those rating systems also take care of those points only which are not going to have a heat island effect removal from Indian point of view. We have imbibed those codes also, and then the fundamental principles of water efficiency, indoor air quality, and what Sir had already said is working on that, material efficiency, material education. So basically, we have to think in a new paradigm shift as an architectural community, as a designers, that something is wrong with it. Oh, sorry, sir. What's here? So basically, the future of architecture is towards bioclimatic only and bionic only. Now the shape of buildings to come is to be less than, and I don't think any other material than stainless steel can suffice for such shapes. Now this is the map I want to show you. If you had seen this map in 930, it was only United States. Now today, the green thinking and stainless steel is in all these blue countries. So you can see that what is the shift, except China, we are not shown because we don't know information regarding China. But China is also a pioneer in green buildings. You should underestimate their. Second is sustainable development examples and life cycle assessment. Now everybody talks about life cycle assessment is 80 years and it's not like that. Indian architects have to think life cycle assessment in terms of total building, not only building costs, building usability and then recapture costs also. So life cycle calculations have to be based. If you go on those calculations, you will see stainless steel is the best performing material. Then I'll go fast through it because this is how the sustainability as per ASTM has to be done for. This is the column is talking of such structures can come in stainless steel only. Now, as Mathur said, you see Chrysler, Empire State Building, this was 1956, and they are still standing as icons of architecture. And this is what happens to other materials, whether it is painted aluminum, carbon steel, aluminum roofs. So it's a commonplace comparison I try to make. Then reducing energy and heat island effect. See, India is a country where we have very high density in terms of public spaces. And once we have high density, we are issues of heat island effect. In Noida, in 1962, when we built up the Quantum building, the temperature inside the courtyard used to be 2 degrees less than what it's today. So as a country, you have to think about this because overall urbanization is very dense, and what they call it the urban massing, and the urban stratos are very, very dense. Then this is the versatile column design, which has to be mimicked from greens. And this is the future of architecture. So stainless steel is the only material. I specify it with all the knowledge I have and the experience we have gained, stainless steel is the only material which can do this job without education of 4-5 materials. Now I come to the basic thing for Indian architecture and thinking in architecture is that we never have divided building, Mathur Saab, into systems. Whenever we talk of building, say there's a structural system, there's a building transport system like lifts, escalators, and then there is a building gray infrastructure system like roads, sewers, blue engineering system like water, transportation of water inside the building, hot water generators. If you see all these elements, building cladding and facade, what we call as building envelope systems, everywhere the use of stainless steel with the world comparison is 10%. Why? Because of plastics and a lot of engineering done in plastics in India rather than in stainless steel. So that people are going back. People are moving back to stainless steel and steel in terms of these all building systems. Now the urban issues of pressure, temperature, this is all engineering what they already dealt. See, what I want to tell you is that if any material has such recycled content and end of life capacity, so there is no thinking about life cycle costs. The buzzword these days are all management jargons, environment, and this is reuse, rethink. That's what stainless steel can actually do for us. Now this is the various properties, will go fast, the technical part of it. Now it's an architect's delight, like railings, it is highly choice of color for the critical selection of right grade. That is basically the quality of application, which we are missing in India. We know that what is the application per se, we know the animal usage, like in railings. But where we officially fail is the application part of the quality control, welding systems, end connections, elbows. So this is one building in stainless steel, which is already there in Las Vegas. So you can see what we can do with stainless steel. What more you can do with stainless steel? It's like a human brain. The architect design is a human brain. So you can see this building always standing. I'm talking about buildings which are already there. Now, for facades, you see stainless steel is a modern material. Now, when you talk of life cycle costs in terms of facades, if you don't talk about the cost of aluminum, Alpro, with the cost of facade generally comes to India to 800 rupees per square feet. If you go with stainless steel, comes to 1600. Now the difference of 800 is that if you see the effect of aluminum after 6 years and silicon replacement 2 years, if you see the maintenance cost of those facades and glass also, when it's fixed, because once aluminum starts blotting and riveting, the glass also gets affected. So in terms of acid rain, pollution, local emissions are talking about India only. And then weather conditions, we are a 4-season country. So with that, I think, and the corrosion of crevices, especially galvanic corrosion, it is one of the best materials that can happen to our great country. This is the corrosion map of India. Now this map itself explains that what stainless steel, why we should go for stainless steel in a very phased manner. Then energy modeling of buildings, what they do at DOE in USA and this part of it, we also do it for GREA rating. It is basically fenestration sizes. Stainless steel is again one of the best materials. Now for postmodern architecture, which is going to come, I think stainless steel is the only material we should do something. If we can't prepare fast codes in this country, we can borrow them. If we don't have them, we can borrow them from developed countries and especially Germany and US. They have very standard codes and very detailed codes. We can borrow them directly and start working on it. Now these are the sunscreens of stainless steel. We have created a roof garden in our building 62, which is round up a half acre on the top of the roof. It is on a stainless steel plate. We did it 10 years back. We got it welded. And this is the other things that happen with stainless steel in terms of facades. Especially when you come to transit buildings, especially when Sir was discussing about stations they are doing. So it's already discussed that. Now structure performance data, the forming part of it, sir. Whenever we, in India, whenever we talk about steel, we always have a thinking about I-beams and hollow box sections. We can't think of any section. So stainless steel can come with octagonal sustained facade, which can be part of facade and part of including interiors also, sir. I think the student should develop that system now. And then water supply, I don't want this all known. Jindal steel does a lot for water supply. We use their pipes. The disaster resilience and disaster management, fire. Now there is no other material in impact and fire, which is better than stainless steel. These are the existing photographs. You see how the towers came down in US. They were in carbon steel only. So, and I should say that we should kindle, all architects should kindle our imagination for cost subsidization, structure and facade fusion. We should go for shell structures, innovative studies for structure connections, fusion of structure, facade, interior cladding, railings as part of it, and regress cost per square feet. Our efforts should to bring stainless steel at the regress cost at par with aluminum and other systems combined. Thanks. Thank you, sir.
Thank you very much. Wonderful presentation. Now I look forward to our youngest panelist sitting on my extreme left, Sandeep Singh. He is the head business development with Jindal Stainless Steelways. And since I am also a director on this company, so I know every 3 months what progress they are making in promoting stainless steel. So Sandeep, your job now.
Thank you, sir. It's audible? Yeah. First of all, good afternoon to all distinguished panelists and this industry colleagues sitting in front of us. I'm Sandeep. It's been more than 15 years playing with the stainless steel in different segments. And what attracts more, this is the ABC segment. We call it architecture, building, construction, because in this segment only we can show or depict our two faces of stainless steel, which is the bold and beautiful. In any particular structure, if I have to give a strength, then I will use the bold part of this stainless steel. And when it has to be beautify or aesthetically pleasing, then I will be using this beauty part of this. So it's a bold and beautiful combination. It's a wonderful combination. Now, and directly coming to this various aspects and the life cycle we have already discussed, I just want to just throw a light where we are heading towards. No, it's about to reach a $5 trillion economy, $5 trillion economy, and contribution of stainless steel globally in ABC segment is approximately 14-15%, now touching to 16%. When we talk about this India, this stainless steel contribution to this ABC segment merely lies between 8 to 9%. So there is a huge gap. And parallelly, this is the irony, the investment and the government investment in the infrastructure project, in the hospitals, in the IT, in the IMs, this metro station redevelopment, this airports, huge project. 10 lakh crores of the government has been, in 3.3% of the total GDP, they are about to invest. Parallelly, we are having this Amrita Station Yojana, where more than 1,200 stations is going to be redeveloped. We are having this, this kind of this budget we are having, and parallelly, stainless steel a preferred choice of the material for this ABC segment. But irony is this, it is not being widely promoted, used. No, this is the gap. And there I just wanted to bring the design consultant, this architects, to bring the notice. Everybody is talking about this is the green material, sustainable material, but the focus, the attention which we need to have on this, when the finalizing the design, the DPR, the stainless steel consideration and the weightage should be more. I just wanted to cite one or two live example why we should have this stainless steel. When we are doing a Nagpur metro station with Shival Manchanda sir, that metro station is the only station which is having this viaduct railing and stainless steel. So we were sitting on the costing department with sir also. So, and the question was, cost was the factor. So stainless steel, say, per cost was 400 rupees per kg, well, as the competing material, maybe the mild steel and all, they are sitting at the 200, 180 rupees per kg. And when we'll call it, Okay, done, agreed. When you, we have asked them to quote, please take all those factors, no? If you have given an opportunity to serve plug and play for this material with this mild steel for 10 years, what will be your quotation if you have given the maintenance part as well? Then they withdraw. And they withdraw by that point, no, we are not authorized to do this, we are not. But the actual cost for this 10 years, 15 years down the line of maintenance of the mild steel railing was much, much more than ours. Same, then we have also approached the DMRC for the viaduct railing. Initially they denied because the cost was 20-30% higher than that, because mild steel railing was using 3 mm, whereas my thickness of 1.2 mm was suffice the load parameters. In the 10 years or 20 years down the line, when the metro has started or incepted in this DMRC, approximately more than 15 crores of rupees has been invested or tender has been floated for this mild steel railing, painting and all. So this is the pictures we have to think about. Now coming to this smart city project. Every smart city we are having this 14,000 lakh rupees or crore rupees we are having for the spend of this smart city. But we also, the people standing before the sale, people also there and auto companies also there. Why don't we should collaborate and go to this ministry and say the material you are using is not for everlasting? Because we have seen in every corners, in gymnasium, the open gym concept is coming in every park. In my nearby park only, it's been, I think, 3 years or more, every gym equipment has been stolen, vanished, rusted, broken. So the amount of judicious investment of this money, of this hours money only, has been not be used properly. If it had been a stainless steel, at least minimum guaranteed warranty of 10, 15 or maybe more than 20 years, because it is not prone to theft also. It is not, ये छोटे grinder cutter से ये नहीं कट सकता. It's very tough to cut. So these are the live examples we are having. Plus, I just wanted to draw attention on all those members here, and I request ISSDA also to think on this. We are, when we are making this DPR or design part, we always consider the durability, life cycle, but we never thought of this carbon emission norms. So whenever we urge our industry panelists and the speakers and the other members also, decision makers, can we have this CO2 emission norms? Clearly make a criterion of this design qualification. So when we talk on this line, so definitely we are talking about sustainability, green energy, green material, green economy, right? And other part of this, I am always in favor of supporting or encouraging our contractors, manufacturer like us. Can we have that kind of proposal where we can ask our executor also use that kind of material is less carbon emission? Can we incentivize them? Is it possible? It's a food for thought. Second thing also, we have came across this GWP parameters, global warming potentials, materials. No, these have a different index which clearly says that use that material which is sustainable, which is long for future and all. I think one more thing I just wanted to highlight, because we always talk about this circular economy, the reuse and use of material again and again. When I was doing this edible oil project with this BIS specification, one of the tanker which was made in 2010 in nearby Ghaziabad only, that tanker, stainless steel tanker, has seen 2 or 3 changes of chassis only. The life of the chassis was 10 years and the tanker's life was unlimited. So that particular tanker, stainless steel tanker, has witnessed 2 or 3 changes of the chassis only, the base, जो truck बोलते हैं उसको. So this is how the magic, it is very, sometimes, I think I should share. वो एक LIC में कहते हैं ना, जिंदगी के साथ भी और जिंदगी के बाद भी, तो वो मेरे को लगता है कि वो शायद स्टेनलेस स्टील को ध्यान में रख के भी बनाया गया होगा. सिमिलरली, सो बहुत सारी ऐसी चीज़ें हैं जिसको हमें लगता है कि नहीं, दिस इज नॉट मटेरियल फॉर द करंट एज, दिस इज मटेरियल फॉर द जनरेशंस वी आर टॉकिंग अबाउट. And we at Jindal Stainless, not only this manufacturing, selling, proposing, pitching stainless steel, we are also creating parallelly a sustainable environment with a sustainable economy also. More or less, now one recent development which we have done in the tunnels also, in this USBRL tunnel which has got 270 kilometers, and out of that 175 kilometers was tunnel. So in that tunnel, when the tunnel design was about to prepared, was the consultant was Amberg and this Geodata also. So we reached to the consultant and say what was the practice we used to follow in Europe, because when we go to the client, this Northern Railway, they were asking, no, if you are proposing 4 times costlier material, it is not possible. Then it was a project of 40-50,000 crore if I add 4x material. तो totality में वो हमारा जो पूरा expenditure है while using this stainless steel is a nominal, only impact is 1 to 2%. It's not only going to distort the entire figure of this 4,000 crore, 40,000 crore. So they went or they opted for this.
दिया सिखा दिया करा दिया और हो गया. So that should not happen. So we have to train technical manpower and about standards, specifications, codes, guides and guidelines is all to be done, to be developed for our contexts, which are very, very important. So why don't we plan and design our buildings and our towns and our smart cities in a way that they're resilient and they take care of climate change and they take care of our context, and that is all I have to say. So we have a very bright future. The next decade is of India. It's not we saying, it's the whole world saying. So we have to prepare ourselves for that. You know, we have to just not miss the train now. That's all I have to say.
Please.
I just have to say, in 20 years of selling stainless steel, this is the first time somebody has said stainless steel is like a theme. I think that's a good selling point. We should be using that more often.
Sir has asked for this training program for this various people, and I think in Jindal Stainless we have one Stainless Academy which have trained almost more than 10,000 people. Earlier we are having this railing, black spots were there. Now at least we can see and observe this after scaling them all. So more than 10,000 I think persons have been skilled that has been given by this Stainless Academy of Jindal Stainless. And one more thing which I just ask Shival Manchanda sir, it's my own request because he is taking care of this Mumbai line 12. So I think what has been done till date, so we will like to see more stainless steel in line 12A of Mumbai railway station. And I also request Bimal Kachroo sir, we have long back planned for this Faridabad station railway development, whole in stainless steel. We can still think of. No, down the line, 10 years before, we cannot say that any architect think something else and we are not able to create. Now we have that kind of gut feeling and that kind of ecosystem where we can promise and execute all those design thinking of any architect. So my request to all architects fraternity and the design consultant, please think of and come to us. We are in a power of and that kind of ecosystem where we can deliver your thought process into reality. Yeah, thank you.
Many thanks to all our panelists. I just want to end by saying that coming together is the beginning. Staying together is progress. And working together will be success. So let's all work together, and we would urge ISSDA and others to arrange a special session for architecture, building and construction. This was just a trailer, you can say, when we have Amitabh Bachchan or Shah Rukh Khan's picture. They want to promote the picture. They have just shown what we did today was like a trailer. If you want to see the full movie, 3-hour movie, we have to have that kind of audience and that kind of surrounding and that kind of ambience. Thank you, all of you. Have a wonderful day. Thank you.
So I have two assumptions to make. Either the panelists have given you so much that you want to mull over it and probably reframe your questions, or the lunch is getting late. So I'll thank the panel here. Thank you so much for the valuable insights and your time today. It's been very informative, very educative, and I'm sure the attendees will carry home a lot of learnings. Let's break for lunch, and I leave you to interact with the panelists over lunch, and we assemble here quickly for the next session so that we don't delay the schedule. Right? Thank you so much.